Okay, so I think today is going to mark the last lecture that will take a exploratory walkthrough on Bomb Lab. So I think after today's lecture, where I intend to be able to get through both phases 3 and 4, I'll leave that last phase up to you as a class to defuse. And of course, using the techniques that we've gone through and utilized for phases 1 through 4. And we'll probably take a look at the next lab in our sequence next lecture. And we'll start walking through and defining what the criteria for that is. And yeah, as I stated just a moment ago, I think moving forward, we're going to just kind of, that's how we'll unfold the content for the semester. Okay, so with that said, we last left off defusing phase 2 of the bomb. So in today's lecture, I want to be much more hands-on with the debugger and in fact, potentially get some input from all of you where we'll collectively debug my sample bomb together. So if we're going to do that, let me hop on. And of course, I have the chat open to here. Are any of my inline online people connected to Zoom out of curiosity? Okay, so I'm going to make this recommendation for online people. If you have a question, does anyone here have the Discord open? Okay, if you have a question for me, please type it into Discord and one of our in-person ambassadors, liaisons, will go ahead and relay that question. Because when I hop into this view, I lose my ability to see your Zoom chat. Okay. So let's see here. Let's get started then. If you recall, and we'll just take a quick look at my phase solution document. The last two phases that we have is for phase 1, it was proton guns are all well and good, but sometimes you need the Swiss Army. And then we recognize that on our second phase, it was a numerical sequence of 1, 2, 4, 7, 11, and 16. So using this document, I can go ahead and run let's clear this. So if we go to DBG, and then we use that on our bomb application. Oops, no. GDB. Use that on my bomb application. Okay. Then what I can do is we can set our breakpoint to explode bomb, because we want to try to avoid any instance where that function gets invoked. So let's do that. And then here, let's also just go ahead and what do I want to do here? I can do a couple of things. Let's do this. Let's run, at least initially, our code with the argument, command line argument of passing in my solution, just to make sure I get to phase 2. So just as a reminder of where we last left off last lecture, let's go ahead and run that. And we see, yes, it went ahead and launched. It shows that the first phase is complete, the second phase is complete. So now let's just type in something. I will type in hello world, and I'll hit enter. And instantly, since I only set the one breakpoint, we can see that I'm in the explode bomb. So clearly, hello world is in it. Let's set a breakpoint now for phase 3, so we can actually start using the debugger to step through what's happening. So let me quit out of this. Okay, let me clear my terminal. Let's relaunch this. Let's go ahead and make that breakpoint again for explode bomb. Okay, now I can do a number of things here. I can, first of all, let me do a breakpoint for phase 3. Okay, so now we have a breakpoint for phase 3. Let's take a look at, let's disassemble phase 3. So oops, you have to have that underscore in there. Okay, we can also just go ahead and use the disassemble instruction on any of our function names, even before we start stepping through our application. So if I want to just take a look at what was happening here, When I go to run my code, I know it's going to launch and it's going to successfully get past phase 1. It's going to successfully get past phase 2. It's going to wait for a prompt to be inserted into the system input stream. And so that's where I'm hanging right now. It's why I provide some data, in which case it'll process on and then resolve this function. So we're inside this function currently. And this is going to be our set of assembly instructions. And I think this is where we last left off last lecture, right? We peered into what was phase 3, and then I challenged all of you to be able to go through and try to parse it. Now, your phase 3 code is probably different than my own, so we'll parse through this together. Okay, but there's going to be some interesting parts. Now, this is much bigger than the last phase, right? There's a lot more assembly instructions going on here. So why don't we just step through it? So there's one of two things that we can do. We can look at every time there's a compare and jump. We know that those are interesting. We can always look for when the explode bomb function is called. That's what we want to avoid. So we want to see what jumps or what conditions are being compared that lead to that function call. And we got to make sure that our input string is in a way that avoids leading us to the invocation of the explode bomb function. Right? That's effectively what's been true for the last phases we've looked at. That's going to be true for all these phases. Okay, so just looking at this, let's just jump up. Here's a comparison. Here's a jump. Here is a call to explode bomb. Here's a comparison. Here's a jump. 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 And a jump. And a jump. And let's see here. And a jump here. A call to explode bomb. Another jump. Another compare. Another jump. Another call to explode bomb. There's a lot going on in here, right? And so when this happens, maybe what's nice is you could either take this code, copy it down, and kind of insert your own inline comments and try to dissect it, or like what we saw, or alternatively, we can step through it and evaluate the states of our registers and see what's happening line by line to try to predict what input is causing us to poke at our bomb, see what leads to an explosion, say, okay, let's not do that next time. So let's do that second approach for this time and see how well that strategy will work out. Okay, so let me go to the next instruction. What did I didn't type in anything. Let me hit quit. Okay, let's clear this nonsense. Okay, so let's start poking at our bomb, GDB bomb, and let's go ahead and set our breakpoints again. Break on phase 3. Let's also set a breakpoint for explode bomb. Okay, perfect. Now let's run with our solution to get us immediately to phase 3 where we care about. Okay, so I know I'm going to explode a bomb when I just type in the string hello world. But why don't we see why that's the case? Let's see what's evaluating that's causing that to not work. So I'm going to do the same prompt that we just did. Hello world. Okay, and now let's just step through this and we'll examine the registers at each time, especially with a careful eye during our comparisons. Okay, so let's see here. So I'm at currently this line right here. So let's just add, which is going to be a lot of the perfunctory preamble of having to start to invoke the function. So let's just go to the next instruction, which is now here. Let's go to the next instruction. Let's go to the next instruction. Okay. Now we're starting to do things. Notice we're moving from this memory address to ESI. So why don't we take a look? Let's use x/s. I'm predicting what that is going to be a string. So let's see what it is. Let's inspect the contents of what's being moved into ESI. So 0x402 78A. Okay, that's my formatted string. This is probably the string it's using to compare against my input. Now, when we have a formatted string, we see it's %D. What data type does that wildcard element in a formatted string normally represent? That's right. That's right. And what do I currently have as my input string? It's text, right? So clearly that's why I'm probably setting off the bomb. I can make a prediction based off of clearly what's being put into ESI, what it's doing its initial comparison for, to see if my input string is even valid before moving on to anything else. Okay. So, so after I do this, next line, and actually, let me see. Also, can I do, it should have been moved into, at this point, it's now moved into ESI, right? So I can see where the string was actually initially declared in the application memory, but then as it moves into my register, I can also validate and verify that. Okay, so now where we are. Okay, so the next thing, so we've moved into our ESI, this formatted string, and then we're going to move into EAX, our accumulator, the value of 0. Okay, so now let's go to next I. So now we're at the scan function, our C code, that's going to scan our input string, get the input we've supplied, which was, in this instance, it was hello world, right? And so this is going to resolve into, let me go to next instruction. Okay, so now I am after the input. I mean, the invocation to the function, not the input, but the invocation to grab our input, right? With the scanner function, right? So when that's called, I'm now trying to compare EAX to the value of 1, to the constant value of 1, right? Okay, so what is inside of EAX at this point? Well, let's take a look. Well, let's just print D EAX. Okay, so the value at my register, then, if I want to display it, I could also have done info register, like I showed you last time, which would also show, this would show me the hexadecimal representation. One of the powerful things about the print statement is it allows me to also re-express or reinterpret or retranslate that data, that numerical value, that numerical hexadecimal value, into a decimal value if I want. Or if I wanted to, I could do X here and get the hexadecimal value of that as well. Okay, anyway, the point is, after the call of scanning, the value is 0, right? And now I'm comparing it to the value of 1, right here in this line, the green that we're currently at. This line here. So 0 compared to 1, and now we're going to do a jump here if we're greater than that comparison. So we have to be greater than 1 to do this jump. And guess what? If we don't do this jump, look at what the next line is. We're going to explode. So EAX is resolving to 0 after we call to scan. Why do you think that's the case? Didn't get a digit. So, but how many, if it does get a digit, what do you think the value will be? Let's take a look. Let's build up an intuition of what's happening. So already we know we can quit out of here. So let's quit and start again. Oh, that's right. That is very true. But instead of reading the man pages, which is the better approach, we're going to play around to see if we can't get an intuition.
Instead of quitting out, you can just run and down.
Oh, thank you. Okay. Okay, let's do this. Break on my explode bomb. And break on my phase 3. Okay, and let's do run on my sol.txt. Perfect. Okay, so let's run this again. And what I'm going to do now is I'm going to do a value of 100. And we know we'll need 2 digits, but what if I do 100 and hello? Okay, let's take a quick look at how this is going to resolve. So let's do next I, all the way till after. I guess I could just set a breakpoint so I don't have to do this again. Okay, so we're going to make our call, and now we're at the compare. If I take a look at our EAX value, you can see it's now 1. Now remember, when we do this comparison, we want to jump if we're greater than the value of 1. That means we have to be 2 or higher, right? So if we were to read the man page, we would see that the accumulator register is recording the number of the correct special wildcards that are abided by our input string. So if we're looking for %D, and we gave it 2 pieces of text, we would get 0 valid inputs. If we gave 1 number, which is, say, for instance, the value 100, followed by a piece of text, 1 of those 2 are valid, so my accumulator is 1. So the idea behind this check is I'm going to check if the input string contains 2 integers and only jump if that's the case. So just to validate that, let's do this again. Okay. So let's do, I'll let the class actually pick the input numbers now. What do we want to put for input? Well, let's try. So let's do which negative numbers? Well, I'll do 1 is a -1. Does anyone have another? Do you want to do 2 negatives, 1 negative, 1 positive? You want to do like 2 negatives, a -1 and a -999? Okay, perfect. So now let's go ahead and see what happens. Okay, so we are now inside. Let's go to our next instruction. Let's go into our next instruction. Let's get to, okay, so we're setting our accumulator register to 0 at this point. We are calling on our scanner, which is now going to update the accumulator. Okay, now we're doing the comparison. So while we're doing that, let's take a look. Let's print the decimal value that's now inside of EAX. And we can see it's now 2. So what that means is we've gotten past the very initial roadblock that can cause an explosion. In fact, that was what was causing the explosion for my hello world input. It was the fact that I didn't provide 2 integer values, and when which resulted in not making this jump. based off of the value in the accumulator, which then led to us exploding. Okay, so now, so let's see what happens next. Let's just kind of step through, and when we get to another comparison, we'll continually kind of explore to see what's happening. So I'm going to do next instruction. Okay, so now you can see I'm told my jump is taken, which is what was not happening before. Okay, so now we're going to do another comparison here. We're going to compare to see what is that RSP plus hexadecimal 14. So why don't we take a look and see what that is? So we're comparing it in terms of a numerical value. It's hexadecimal. Let's do this. So let's use X. And so we'll keep it in hexadecimal notation. What is this? Let's do RSP, and then we'll add to it there we go, that offset, and it looks like that is, let's do this, -1. Oh yeah, that's right. That is what our input was. I forgot that we did negative numbers. I'm like, what is this strange number I'm looking at? Yeah, we didn't do positive numbers. We were playing around. Okay, so now we are looking at a -1. So that's our input. That's the first parameter that we passed in. Okay, so now we're going to compare that to the value of 7. And then if it is above 7, right? If the result of this comparison is if it was above, then we're going to jump to this address right here, which is 151. Let's let me see here. Where was that? Where would that jump? Let's take a look. If we don't, let's do this. Let's disassemble into phase 3 and see where that jump, just out of curiosity, where that jump goes to. So that's a comparison. Okay, so jumping back into here, we're right here. We're on this line right here, right? And in fact, it shows us by the little arrow next to it where we're currently inside of on this function. Okay, so where is that? Okay, so now we're going to jump here if it's above, and we can see that jump is going to go to 12, 11. Oh, look, that's not a good jump to make. We don't want to make that jump. That jump goes to an explode bomb function call. That jumps us right into a function call we don't want to be in. So that means we want to be above 7. I mean, we don't want to be above 7. The reverse of that. We want to be below 7 or at 7. Right? Does everyone kind of see that? Intuition, at least, just kind of walking through this. Okay, well, let's do the next. Which we are, right? We're at -1, aren't we? We're comparing -1 to 7. If we're above 7, then we jump to the bomb. So presumably, we're not going to jump to a bomb now. So let's move to the next instruction where, let's see here. Where are we at? Okay. Yeah, so. Okay, yeah, so we're actually at the evaluation, the jump. So let's go to next I. And here I am. Oh, wait a second. Am I inside of a... I am inside of an explode bomb. So a bomb had exploded. I have to look at the function call, but I wonder now if it was changing my signed value into an unsigned value, which would then mean that I was above 7.
It was above and not green.
You're right. It was. So that means it was for unsigned data, which means the negative value was not treated as a signed integer, it was treated as a as an unsigned integer. And so which means my most significant bit is gonna be a really big number. Okay, so now we know our value, because of that, though, that was a good suggestion, because what that means is that our value has to be between 0 and 7 to get past that next phase of the bomb, right? If we try to select even a negative value when it does that comparison, it's going to treat it as a very big positive number, and then we're just going to blow the bomb up. Okay, so let's try running this again. Getting lots of good insights on this. Okay, so we know now that the first digit has to be between 0 to 7, right? We don't know what the second digit has to be. We just know it has to be a digit, because we haven't explored that far enough to see what causes the next bomb explosion to go off. Okay, so I'll ask the class, what do we want for the first digit? 5, 4? Okay, we'll do 5 then. And what about the second digit? You want to do 4? We'll do 5 and 4. Okay. Now let's step through this. Let's go to next I. Yep. Next I. Now, clearly I can set breakpoints and then just select to continue, but I think there's a value to see line by line what's executing as we progress through. Next I. Okay, we're calling our scanner. This is the first time that we evade the bomb. Okay. Now we're doing our comparison. And we're going to jump if it's above, which in this instance, we have a 5. So we should do that. Or we shouldn't do it, right? We're not going to jump this time into the bomb. So now the next thing we're going to do is we're going to move into EAX this value. Let's see what that is. All right, let's take a look at this. So let's print, and I'm just going to print as a decimal the value that's at RSP, and there we go. Let's see what we're moving here. Okay. Yeah, let's do that. Or you know what I'm going to do? I'm just going to go to next I, and then we'll just take a look at what's inside of our EAX register. Okay, so let's take a look at this. First of all, what's inside of EAX? Oops. Oh, the value 5. That's our second parameter. So now we've moved into EAX, our second parameter. The next thing we're going to do is we're going to jump. So let's go ahead and just do it. I could, like I did before, disassemble and then see where I'm going to jump to. But you know what? Let's just do it. See where it brings us. Okay, now we're going to move into EAX 0. Okay, so let's do next I. And now we're going to jump again. Okay, well, let's do that. Now we're going to subtract from EAX some hexadecimal value. Okay, well, it's mutating EAX. I can keep examining it, and we can see how it mutates each time. Let's see here. Okay, next. Yep, okay, it's been mutated. And now, let's yeah, and now let's do this. And we can see, it's been mutated again. Okay, let's do that. And we can take one last time. Okay, it just keeps oscillating our EAX value. Okay, okay, so now the next thing we're going to do, though, is jump. It's a good thing we're about to jump, because to 161, which is going to be right here. right? It's a good thing we're about to jump here because the next instruction was going to be a call to a bomb. Okay, so now what we're doing is we're doing a comparison of our D word pointer. So let's take a look at what is there. Let's do XX and let's do RSP plus 0x14, which that should be our argument, right? Yeah. And again, I could also do this as a D. Just see the 5. Okay, so we're going to compare our second argument at this point to the value of 5. And then, we're going to jump. Okay, let's see what happens. So right now, this is going to be equal, right? We have 5, and we're comparing to 5. And so if we are greater than, we're going to jump to 174. Oh, well, that's good. We don't want to be greater than, right? Because we jump right into a bomb. So let's see what happens. So I don't take that jump. So let's move on. And now we're going to compare EAX to the value in that pointer. Let's see what it is then. Let's print our value of EAX. Oh yeah, we did some weird things with the EAX, didn't we? Okay, well, let's take a look at what's happening here then. Let's print what's inside of a let's use X. I have to use X because it's in memory. Let's print what's inside of RSP and then 0x10. Here we go. Yep, that's our value. That is that our second parameter? So that's our so we're comparing our second parameter to EAX, which is not going to be equal. I can tell you that much. And looking at after this comparison, we're going to do a jump based off of equality. And so, in fact, our jump is what we want to do here, right? I kind of want to do this jump. It's a big jump. Because if we don't do this jump, we're going to explode this bomb. So, I don't like how that's looking. But we'll take a look. Let's finish this through. Let's do next die. Yeah, we're not going to take that jump. Makes sense. And oh no, what is going on here? Yeah, we're on the explode bomb function, which kind of anticipated. So yeah, that second value did not work out for us, right? So, but now the question is, what was EAX? Was it minus 349? So let's see if we can't pass the minus 349, and if that won't allow us to get through. Okay, so let us run. Okay, so the first one was 5. 5 worked for us, right? Now, did we want to try minus 349 as the second term to see what happens? Okay, let's do next time. Actually, let's see here. Let us disassemble phase 3 and actually set a breakpoint at this point to that comparison we care about. Okay, so where did we last? Was it where was that comparison at? So I see we had a jump. It was this one right here, right? Was it this one that we last? Or was it? No, it was a comparison. It was this one right here. It was the comparison to EAX, right? And our parameter. Yeah, so this is, so what I want to do here is I'm going to just grab this. And let's just make a breakpoint here. Oops. Oops. Gotta put my asterisk in front. Okay. So now I can just go ahead and hit continue. And now I should be at this line, right? I'm now at the line where we last left off. Okay, so we're comparing that. So now let's inspect again. Let's take a look at print X. No, so let's do print D. EAX. Okay, minus 349. And now let's take a look at our X, and we will examine this as a D, and let's do RSP, and let's do our offset. Ah, okay. I'm liking this so far. So let's go to next instruction. And the jump is taken, right? It says I took the jump. So now I'm going to add to my RSVP. Let's go here. And now I'm at the return. Ah, that feels good, right? Phase diffused. So now we can update. What was it? It was 5 and minus 349. So let's go and update our document. Let me exit out. Oh, quit. Let us go into our and 5 and minus 349, right? And now let me, oh, no escape buttons on the stupid smart keyboard. Okay, now I got it. Oh, I should save that, right? Quit and let's, okay, perfect. Just check. Perfect. Okay. So now let's do this again. Let us do GDB. Let's go into our bomb. Let's set our break for not bread. Explode bomb. Okay. And now let's try running our with p sol.txt. And if this works the way we anticipate, yeah, we are now at the halfway point. We've gone through 3 phases. So why don't we do effectively the same thing we just did and see if we can't explore the state changes of our application to see what input leads to bomb explosions and what input can potentially get us to jump out when we evaluate these conditions. So let's do this again. Okay, so I need input before I can start doing this. In fact, let me do this first. Oh, I can't, I need input regardless. I can't work it with anything in the debugger while it's waiting for something to go into standard in. So what do we want to type in? What do we want to sample input? Do we want to do our default of hello world or do we, huh? Okay, we will stick with our default. I'll put that in and it's going to lead probably immediately to an explode bomb. So hello world is still not the solution, but let's take a look at this. Let's disassemble phase 4. Oh, okay. Phase 4 doesn't look as lengthy, at least in terms of instructions, as phase 3 did, but there's some interesting things going on here, huh? Okay, so we have our preamble stuff, and then we're going to move this probably formatted string. So we'll probably want to take a look at this formatted string. Let's take a look at that, in fact. Why don't we take a look at what's inside of 0x What is that? 40278A. Oh, look at that. Our formatted string. So we know we need two numbers. So we can at least get past the first phase. Now we know why we at least blew up. So effectively, before it's calling our scanner, it's going to go ahead and load the type of format that it anticipates to be scanned in. And then that means our EAX register is going to be updated like the last time. But notice this time it's doing it differently. It's the same check, just in a different way. It's going to go ahead and compare EAX to see if it's actually equal to 2. Or if it's not equal to 2, it's probably going to jump us to a bomb. So here it's going to compare 2 to EAX. There's 2 digits it's looking for. So then if it's not equal, we jump to 447 or our phase 4 plus 47, which is right here to explode bomb. So that's effectively the same way it's enforcing what data types you're passing in. So now we know that. Okay, well, so we can get that far. Let's do that then. Let's just rerun with psol.txt. Okay, so now we know it has to be at least 2 digits. What 2 digits should it be? Six and 7. Let's do it. Okay. So okay, let's go to the next instruction. Uh-oh. Thank you for pointing that out. I need to make a breakpoint for phase 4. That's what I have not done yet. Break phase 4. And now let's rerun. Okay, so we did 6, 7. Is that right? Okay, so now, okay, preamble. Okay, now we're loading that formatted string into ESI. Now we're resetting the accumulator. Now we're calling to get our input from standard in. Now we're going to compare our accumulator to see if it is 2 digits, if we read in 2 values. Now we're not going to take that jump because that jump was taking us to the bomb. Okay, so let's see what happens next. Now we're going to move into EAX. Oh, one of our arguments, right? And we can double check. Let's double check that. Let's take a look at RSP, right? Plus 0x14. And we can see, oh, that's 6, right? That's our first parameter. So we're going to move into EAX, our first parameter. Okay, and now what we're going to do is, let's do next I. And let's do next I again. So here we're going to test EAX to EAX. Does anyone know what that does? Yep. That is, so let's see what's going to happen here. And of course, we will now take that jump, which is a good thing, I think, because that jump leads us right to a bomb. So what would EAX have to be for us to have taken that jump? Because we did an input that was correct for this particular instance, but we should have insight as to why. Let's see here. Let's actually, just to modify, I have an idea. Let's run this again. Okay, we did 6 before and 7, right? Curiosity, let's see what if I do -6 and 7. Okay. Next die. Next die. Next die. We're now checking the formatted string. We're updating the accumulator. We're calling our scanner. We're gonna check the number that we have. We don't take the jump because we had two valid integers, right? We're gonna move the first parameter in, which now is a -6. And now we're gonna test EAX to EAX. And now look, you see that? That's what's different, right? When we do tests on ourselves, and if it's a negative value, then you're gonna take that jump, the JS jump. So this is, now we know that this is an enforcement that our first parameter has to be a positive value. Or 0. Yeah. More appropriately, a non-negative number. Exactly. Okay, well, let's do this again. Let's go back to the original because we didn't explode, but we should have at least stopped and have some insight as to what would have caused us to explode. Because if 6, 7 isn't the right answer, we don't want to backtrack and get stuck at a bomb we got past earlier, right? Okay. So we did what, 6, 7? Okay, so stepping through this. Got that. Got that. Got that. Yep. We're going to load in the formatted string. We're going to update. We're going to reset, undo, set 0 our accumulator. We're going to call our scanner. We are going to go ahead and do a comparison to make sure we got 2 integers. We won't take that jump to explode because we're valid up to this point. We are now going to move our first argument into EAX, which is a 6. We're going to evaluate it to make sure it's not a negative value. We will not take this jump and explode. Okay, now we're going to compare EAX. Let's see what's inside of EAX, by the way. Let's do a print. EAX. Okay, so we, 6. 6 was the value. So we did 6, 7, right? So we're going to compare our value in the EAX, 6, to the value of hexadecimal E, what is that, 14? Okay. So and then we're going to jump if less than or equal. Well, 6 is less than or equal. So we're going to jump. Let's see, where's that jump going to go to? 52. Oh, look, we want to do that jump because the next line is to explode. So we did a good thing again. But now we have a little bit more insight. If we don't win this round, we have more insight of what to kind of build our next prompt to be. Okay, so let's do our next instruction. Yeah, let's take that jump. I'm happy with it. Okay, so now we're going to move into EDI. Oh, are we, let's take a look. Let's take a look at what we're doing. So we're going to do RSP and so that is our first parameter still. So we're going to move our first parameter into EDI. And then we're going to move into EDX, that value of 14. And then we're going to move into ESI, the value of 0. You know what we're doing? We're starting to load in a set of parameters for a function call. And there it is. We are going to call some mystery function. Oh, what's this mystery function do? Interesting. Let's take a look at that before we jump into it. Copy that right. Where are you, function? Okay, let's do this. Well, you know what? I'll step into it. Or what I can do is, won't let me. I wonder if I can do probably won't let me do it like func4. Ah, yes. Okay. So what is this going to do? We move from EDX into ECX. We move into ESI, EDX. Oh, we're going to subtract. We're subtracting ESI from EDX. We are going to move EDX into EAX. We're going to do a shift right by, what is that, like 31? We're going to add EDX to EAX. Then we're going to do an arithmetic right shift by 1, which is like doing a division by a multiplier of 2, right? Like a power of 2. Then we're going to add our ESI value to EAX. We're going to do a comparison. And now we're going to do a couple of jumps. So this looks like probably a selection statement. If it's less than, then we're going to load up this value here into EDX. And then we're going to, oh, look at this. This is going to be a recursive function. Because we're calling ourselves inside of this function. Then we also have this jump here. Load into effective press there. Up. And then we're going to jump to 55. That would be to move this. Oh, so that would actually return us out then. Then, okay, so if jump less, then we would go to line 32. That would be here. So we move into EDX 0. Okay, this is actually an interesting function, right? Let's see what happens though. Let's just go to next slide. Well, we're going to do a decomposition of this. I think we're going to have to know what's actually happening here to figure out what our input's going to be. But let's just see what happens before we do the decomposition. Let's just see what results into our final demise with this bomb. If we get there, maybe we're lucky and you gave me the numbers that are just go ahead and pass it. Okay, so yeah, we're going to move into the value of 14 into EDX. We're going to move into 0, the value of 0 into ESI. We're going to call our mystery function here, which is some kind of recursive function that's going to result into something. Let's just do next I. I mean, I could step into it. We could see what our values are, but I'm not going to do that. I'm just going to see what gets compared. Okay, so this is the big thing. So we call the function, and now we're doing a comparison. We're comparing 1 to whatever's in EAX. So let me go to print X. Yeah, we can do X. And now let's do EAX. Oh, it's a value of 6. Okay, so we're going to compare 6 to the value of 1. And if it's not equal, so this is the big thing. We know it's not equal, right? Our EAX register is 6. Our value we're comparing it to is 1. We're going to jump to 83. Oh, no, this is not good, guys. This is not good at all, y'all. We're going to jump here, and then we're going to explode the bomb. Okay, well, let's verify that we have a good understanding of this. Yeah, okay, we're there. And we took the jump, and now we're gonna do this exchange, and now we are in the bomb. So yeah, results in a failure. So we clearly need to know what's happening in this mystery func4 to find out how to get a value that resolves to what. What's the value that we were comparing EAX to? 1. Okay, let's take a look at that. Oh, I haven't had to use any of these slides because we've just simply walked through everything. But I think at this point, it will be advantageous for us to take a look at these slides. So, okay, let's do a quick dissection of this. If we were to look at each of these lines one by one, let's examine what occurs. We move our value from EDX to ECX. We subtract from ESI, subtract ESI from EDX, and we store that into our EDX. We will move the value of EDX into EAX. Right now, we just want to make sure we are understanding the logic of each line. And the next slide, I'm going to retranslate this function into something that's a higher level in SID. So what I want you to do at this point is just make sure that each of these line comments, I don't want you to try to demystify what this code does as a whole. I want to make sure, first of all, that you can comprehend what's happening as a per line instruction. All right. So just stick with me for that. And then we're going to then try to figure out how it works together. So once we understand what's happening with the individual instructions, we're going to piece it. So then we're going to do this logical shift right in EX by 31 bits. Then we're going to go ahead and add EDX to EAX and store that result into EAX. Then we're going to go ahead and do an arithmetic shift, write the value of EX by 1 bit. Yep. Here we will then add to ESI to EAX and store the result in EAX. There's a lot of arithmetic operations happening here. Now we're going to do a comparison. We're going to compare the values of EAX and EDI. And then we're going to jump to some other memory address. So this is effectively, looks to me like a selection statement, but we're going to jump if EAX is less than or equal to EDI. And then we'll load the address that's here inside of our RAX register -1 into EDX. We'll do our recursive call to our function 4 if we hit this line. We will load the address into EDX. We'll jump to 55, which is here. If we get here, this line sets EDX to 0. This compares our values of the EAX and EDI. This will do a jump to some memory address if EAX is greater than or equal to EDI. This is going to load the address that's given here into ESI. This line is going to move the value from ECX to EDX. This line is another recursive call to our function. Here, we're going to load some memory address into EDX. Here, we're going to move the value from EDX to EAX. Finally, we have our return. Okay, so without talking about how this actually works to do anything, does everyone at least agree that the line, the descriptions match with what the lines do? I'll give you just a moment to take your assembly knowledge and just make sure you're understanding line by line, because it's important when we start trying to decipher what's going to happen here, that there's that understanding. Okay. Well, let's translate that and see if now in this translation, in my attempted translation here, I'm going to have effectively the C code equivalent and then the line by line instructions that we just looked at that will go ahead and convert this into something that's a little bit more readable at a higher level. So we can see, oh, look at this. This is a, looks to me like a recursive function that's going to do a binary search. And then based off of the binary search, it's going to go ahead and resolve a value. So if I have my function and it takes 3 parameters, as we saw was loaded before we called this function. So let's call the parameters to our function the same register names they are in assembly, so we can map it one-to-one. So I'm going to have my EDI, which is whatever we supply, right? That's our parameter. ESI is loaded for us, if you recall, inside of the phase 4 function. It set that to 0. So one of our parameters will be 0. but for the purpose of this function, I left that as a, I left the label there so that it matches with our command line instructions. And then EDX, whenever we see EDX, we can think of the value of 14 because that's what's effectively passed. So really, there's only one argument that we provide into this function, which is going to be whatever our parameter is. Okay, so what are we doing? We're going to set EDX to ECX, right? Which is effectively high-level logic here is we're setting a max value for use in a binary search algorithm. Okay, then I'm going to take and subtract from ESI. What? This hasn't been on the entire time. Is that like 9% battery? Okay. So EDX is going to represent effectively a max value in a binary search. I'm going to start to unveil what the logic of this is now that we're looking at it a higher level variant. And so what that means is ESI is going to be effectively what your minimal current value is inside of this binary search, which means that EDI is going to be some value that we're comparing towards. So we're going to see how this works in a moment. So whenever we see this value here, we're going to say, oh, we're setting the max value. We're going to say, oh, this is going to be the difference between our max value and our min value. So this is going to be the total range of values that you can search with a binary search algorithm. And then we're going to just take that result and then move it into EAX, into our variable here. Now, the next thing we're going to do is we're going to take the unsigned, to keep this similar to the assembly code, we're going to take the unsigned integer of EAX, and we're going to right shift it by 31 spaces. Another way I could have expressed this is using the conditional expression, where if EAX is less than 0, then I return the value of 1. Otherwise, I return the value of 0. And then I would add to EAX my EDX, right? Because that's what I'm doing here. I'm effectively getting my most significant bit. If it's a negative number, it's just going to be 1. If it's a positive number, it's going to be 0. And then based off of that, I add that to my EDX. Why am I doing that? It is to go ahead and check for effectively an overflow condition between our this last operation we did, which was a subtraction operation. Okay, anyway, so the next thing we're going to do is we're going to do that division by 2. We're going to take the halfway point. And remember, the halfway point was based off of just doing this right shift by 1, which means that we reduce our number by a power of 2, the equivalent of dividing by 2. And then I'm going to add the midpoint value from our min value. So I have my midpoint. I'm going to add that to the midpoint to my between my range. I'm then going to do my offset towards whatever my ESI value is, which is 0. But you know, in a binary search, you don't always have like 0 to some other number.
I was like when I was looking at it, I was like, I like looked into it and I found that like basically, sorry, so like arithmetic shift right and dividing by 2 are actually slightly different.
They are. You're right.
Yeah. So.
But for the intents and purposes of kind of deciphering this particular function, that's what is going to behave at for what we're doing. But you're right. Like,
but what I want to say was like that accounting for the negative is actually like that +1 is what fixes the shift right to make it the same as
because of the way, because of the way that the complements end up working. Yeah. It's to go ahead and very good. Thank you for the insight or the addendum. But yeah, like because that does bring up a good insight that like we're not really doing division when we do these shifts left and right, and it creates artifacts in our binary sequences that you have to prime for ahead of time. And then here we're going to add to the midpoint our min value, but our min value, at least currently, is 0. But if you know anything about binary search, if we recursively call this function at some other time, the min and max values can change over time, right? So we have to offset that. Then we're going to do our selection statement, which is actually now going to make the decision point about whether we fall, whether our user input, our parameter, falls towards what side of that midpoint on our current execution of binary search. So if our midpoint is less than our user input, then we will set our EDX to 0, and they will check to see then if the midpoint is greater than or equal to our user. That means it's equal to, right? So if the midpoint is equal to the parameter, then we're going to return 0. If it's not equal effectively, but it is greater than, then we're going to set the minimal value, so our ESI, to be equal to the midpoint plus 1, which is what you typically do. Like when you find that a number populates somewhere on the right-hand side of your midpoint value while doing the binary search, you update the min value to be the next value after your midpoint. Then we're going to restore our original max value and recursively call our function. And when we do, notice what we're going to do is it's going to be whatever the result is times 2 plus 1. So that increment of plus 1, pretty interesting. Otherwise, if it's not in our outer loop, otherwise, if our midpoint is greater than our user input, we fall on the left side, then we'll set our max value to the midpoint minus 1. We recursively call our max value again, and we will multiply that power by a value of 2 and return that. Okay. So it's fine and dandy for you to understand this logic, but let's actually touch the logic. Let's take the C code and escalate it one level even higher than that, and let's implement it in Python. And then let's play around with it, which I show you my sample code here. So we already stated in this instance, while we were playing around, that our number, I don't know if we played around to it to this degree, but our number has to be between 0 and 14, or we explode the bomb, right? It can't be a negative value, and it can't be greater than 14. I forget if we tested all those conditions. So now knowing that our first value has to be between 0 and 14, but has to resolve after this function call of being a 1, let's see what possible values that is. So, okay. So I'm going to take our function. It maps pretty nicely here. It maps pretty nicely as a Python function as well, and I'm going to call it func4 if I pass it in 0. Okay. So first, what's going on? Func4, pass it in 0. Okay, so clearly, I'm always going to get that. I need that plus. So here, what inputs could potentially lead? So clearly, nothing from when the middle point is from 7 or less, which we should have already understood reading the source code. But this kind of validates and verifies that. Okay, so let's do it this way. Let's go up. 8 is a possible 1 that resolves to a value of 1. Okay. 9 is too. 10 isn't. 11 is. 12 isn't. 13 isn't, and 14 isn't. There's 3 possibilities that will allow us to resolve with an EAX value of 1 after that function gets called. We can test this out if we want by using these values, but I'm kind of running out of time for this lecture. So let's pick one of those then. Which one do you want? Let's do 11. I like it. So let's go back over here. Run. No. Okay, so 11 and the next term we had a 7.
Sorry, one of the terms was directly compared against one, right? And then the other one.
That's right. I think it was the first term that we were comparing originally just now. We haven't done anything with the second term from what I remember. So our first term, we originally were doing 6, 7.
Yeah.
So let's do 11, 7, because we don't have any insight about what's happening with that second parameter yet.
We were comparing the 6 against the 1, though. So I think the first parameter has to be 1.
Oh, maybe.
Right.
Yeah, you're right. Maybe I'm reversing this. We'll see. If it explodes, then we'll just invert it.
Yeah.
Okay, so let's do next I. Let's do next I. Next I. We'll step through all the code all the way until we get to that function call, which I could put a breakpoint in, and I might. Okay, we'll do that comparison to, so that's just checking our inputs. Now we're moving that first parameter, we're moving the parameter EAX, right? And now we're testing it to make sure that it isn't negative. And now we're not going to take that jump, which was going to explode us. And now we're comparing EAX to 14. And if it's less than, yeah, so we had looked at this before because we didn't blow up because we had 6, but we evaluated this before. That's how we know the number has to be between 0 and 14. Now we're going to move our data into the register so we can make this function call. Okay, now we're doing this function call right now. So now let's do, okay, so this is where we last left off. Let's print our value of EAX. Which is a 1. 11 resulted in a 1, and then we're comparing it to a 1, which means that we're not going to jump into the bomb. Okay, so that's good. So 11 has worked. Okay, so, wait a second. Look at this. Now we're doing another comparison. Let's see what this is. Let's, no, I got to use X because this is in the memory. RSP plus 0x here. So let's see what this is. I need some space. Oh, this is our 7. So we're directly comparing the second argument to the value of 1. So, and what do we want? If we're equal, then we're going to make this jump to 90, which is right here, and exits it out, but it's not. We're going to do 7, so we're going to fall right into this bomb again. But I think that just means that the second argument has to be 1, and then we have it. Let's make sure that we actually fall into the bomb. And we do, okay, so let's one more time with the appropriate output. So we said 11, I'm just going to run it too. We said 11 or 1. And let's just do continue. That worked. But when we were testing this out, oh no. Hang on. Okay. When we were testing this out, we got 2 other possible values. You want to see if they actually work as well? Let's do it. So based off of our examination, it wasn't just 11, it was 8 and 9. So let's try 8 and 1 and continue. That one works as well. And so let's do that again. 9 and 1. So we can see this particular problem can have up to 3 solutions that will allow you to defuse the bomb. Excellent. I got exactly where I want to get today. Just kind of exploring the debugger, working in kind of a classroom setting to work on phases 3 and 4. And that's what I'm doing with this particular lab. I'll leave the last phase, phase 5, for yourself to kind of discover and talk amongst yourselves about, and we will pick up with the next lab, next lecture. Okay, I'm running a little bit over, so I will bid you all farewell.
And are you can upload your slides and the video?
Yeah. So the immediate after this, I'm going to clear up my hard drive space. So I have more than 2 gigs, which will allow me to download the videos and then upload them.